Hey everyone, happy Monday. I hope you are having a great start to the week. I am Mrs. Demyers, Mr. Vandergrift's student teacher, and I am here to go over lesson 2.7 with you, claims about the moon jelly increase. But before we start, I want to encourage you, since this is the beginning of the week, to take a moment and write down 3 goals for the week. Now, those goals can be anything from working on a book or finishing a book to trying out a new recipe if you like to cook. Maybe it's helping out around the house or helping with your siblings or helping with your parents. But I want to encourage you to write down 3 things you want to do this week and stick it on a sticky note or stick it on a piece of paper. What I do is I have sticky notes, these guys all over my desk. I have them like lined up, and that's kind of my weekly goal list, to-do list. And that kind of helps keep me on point and keep me focused. So I'd encourage you to do that. And I want to share with you a couple of my goals for the week. My first goal is to read through more of this book, at least 2 chapters. Mr. Vandergrift gave me this as an awesome resource for me to learn how to be a science teacher. So this is one of the things I'm working through. My second goal for the week is to fix my tomato cages. So one thing about me, if you watch my video, you know that I love gardening. And I built these cages last year, and as you can see, they're falling apart. So this was the first time I ever attempted building cages by myself in my life. And I learned a lot, and sometimes we can learn more from failure than our successes. And so with these falling down, I definitely learned some little tips and tricks. So hopefully I will get those completed next week or this week, and I can show you my completed cages. And my third goal is to work on studying for the RICA test. This is a test I have to take in order to be a teacher. So I got to study for that. That's like a big, long 4-hour test, mind-blowing test. So working on that. All right, so let's go ahead, write your goals down, stick them somewhere you can find them, pause the video if you have to, and then let's go ahead and get started with lesson 2.7. First of all, lesson 2.7, our learning intentions. So our learning intention is that all students will have a better understanding that ecologists must consider different aspects of a sample to make sure that it represents the whole population well. Our success criteria. After we're done with this lesson, I can successfully apply the concepts of population changes and create models showing how the populations of zooplankton and leatherback turtles have a direct correlation with the moon jelly population. In addition, after this lesson, I can evaluate evidence and rank it from most important to the least important based on the information provided on the evidence cards. So during this lesson, we're going to be making models. We're going to be using evidence cards to support our claims. First thing we're going to do, I want you to break out Moon Jelly book. Should have this guy right here. Go ahead and open it up to page 61. I want you to read through page 61. And as you read through it, just like the directions online say, you're going to go ahead and underline the unit question and go ahead and take 30 seconds to write down your question, or excuse me, write down your answer to this question below the question. You're going to go ahead and underline that chapter question. Take 30 seconds and write down your answer to this question below the question, and then go tell your fabulous audience. Now remember, your fabulous audience can be anyone in your home. It can be your parent, it can be a guardian, it can be your sibling, it can even be your toys, a stuffed animal, or a pet. It's just someone for you to talk to. And then make sure you read through all the key concepts, annotate that text, so underline things, and below the key concepts, write down one previous experience that you have seen that relates to these key concepts, okay? So go ahead, pause this video, and go ahead and complete the instructions for page 61. Okay, so now that you're back, we are going to go ahead and move on to the warm-up. So go ahead and turn over to page 62. And as I was looking through this warm-up, I was asking myself, what is a walleye pollock? See, I've heard about a lot of different fish. I've heard of salmon, I've heard of halibut, I've heard of tuna. I love sushi, albacore, yellowfin. Sushi is awesome to me, but I've never heard of walleye pollock before. So I was like, well, what is this? Well, whenever I don't know something, I Google it. So Google to the rescue. These are walleye pollocks. And here's some more walleye pollocks over here that are dead. And I saw there are a whole bunch of them that were obviously, they're out of water, so they're dead. So I thought, well, I wonder, what do we do with walleye pollocks? Like as humans, do we eat walleye pollocks? Once again, I Googled it. And I found out we do eat walleye pollocks. And this is how we eat them. Now, take a look at that and think in your mind, what do you think that is? And if you guess fish sticks, you're right. So I was looking at the fish stick box and I thought, okay, are these really walleye pollocks? So I Googled it, picture of fish sticks came up. But, let's just see, is there really pollock fish in here? Sure enough, flipped the box over, found a picture of it, And on the ingredients, first thing, minced pollock. So now we know walleye pollocks. If you've ever eaten a fish stick, you've eaten a walleye pollock. All right, going back to our warm-up. So on our warm-up on page 62, there's a picture of this glacier seafood web. Now, if you remember, we have the arrows are pointing this way, but it doesn't mean that the algae is eating the zooplankton is eating the moon jelly. It's the other way around. So the orcas eat the sea turtles eat the moon jellies eat the zooplankton. The walleye pollocks are fish sticks. They eat the zooplankton. The zooplankton eat the algae. And remember, these arrows here represent the energy storage molecules. So it's the transfer of the energy storage molecules. Go ahead, take a look at the questions on page 62 and go ahead and write down your answers. So our first question is, what could have caused births to increase in the moon jelly population? And our second question is, what could have caused deaths to decrease? So go ahead, pause this video, and complete your warm-up questions on page 62. Okay, so now that you've completed your warm-up questions, did you tell your fabulous audience about your answers on page 62? If you didn't, pause this video and go tell them right now. Okay, now that you're done telling your fabulous audience, I want to take a moment and show you what I wrote down for this. So in regards to the question, what could have caused births to increase in the moon jelly population? I wrote down that an increase in zooplankton could have caused an increase to the moon jelly population. And in regards to what could have caused deaths to decrease, I said a decrease in sea turtles could have caused a decrease in the number of deaths in the moon jelly population. So if you have anything written down like mine, make sure you go ahead and just underline what's similar. And if you're missing part of this, make sure you go ahead and write it in, okay? So moving on, we're looking at our chapter question of what could have caused an increase in births or a decrease in deaths in the moon jelly population. So again, here's our glacier sea food web. And remember we talked about earlier how our energy storage molecules are going this way, and how we talked about how the orcas are eating the sea turtles, and the sea turtles are eating the moon jellies, and the moon jellies and the fish sticks or the walleye pollocks are eating the zooplankton are eating the algae. And even down here, there's another correlation between the sea urchin and the kelp. So the sea urchin is eating the kelp. Now, if we have an increase in the zooplankton population, what happens to the moon jelly population? Well, if there's more energy storage molecules hanging out here, or there's more births, or there's more zooplankton, there's going to be more energy available for the moon jellies. So the moon jelly population could increase. Now, if our sea turtle population decreases, what does that mean for the moon jelly population? Well, if there's less sea turtles swimming around, that means they're not eating as much, and so they're not consuming as many of the energy storage molecules from the moon jellies, which means there's more moon jellies that are going to be alive. So what we want to do with that information that we just discussed is we want to take a moment and actually make a model. Okay, so the purpose here is to make a model so we can show the relationship between the moon jelly and the zooplankton population. Now remember from chapter 1, we made a model where we showed that the population of the moon jellies increased because either births increased or deaths decreased. And on our model, we represented births with a B, and we represented deaths with an X. And so when we showed that births increased, we showed this by having more B's over here than over here. So right here, before 2000, we have 2 births, and after 2000, we have 3 births. Now we have the same amount of deaths. In regards to the deaths decreasing, before 2000, we had 2 deaths and 2 births. Then after 2000, we have the same amount of births, but we have fewer deaths. So we only have 1 X here versus 2 X's over here. So we're going to take what we did in this model here and apply it to a model that includes both the moon jellies and the zooplanktons. So I want you to take a moment, pause this video, and read over page 63 really carefully. In fact, you may want to read it 2 times, just so you have a full understanding of what we're going to do next, okay? So go ahead and pause the video. Okay, so you read over page 63. Now we're going to go ahead and make a model, so make sure you flip the page over to page 64 and go ahead and follow along. You should see this model right on page 64. So our goal here is we're going to show how a change to the zooplankton population could have caused births to increase in the moon jelly population. Because again, we're answering that question, what could have caused an increase in births or a decrease in deaths in the moon jelly population? So already filled in, these are the populations in a stable ecosystem. So in a stable ecosystem, we have 2 deaths and 2 births in the zooplanktons. And in the moon jellies, we have 2 deaths and 2 births. Now, what happens to the population during a moon jelly population increase? Well, first thing we're going to do is we're going to show more births. So here I decided to stick 4 births in my boxes versus the 2 we have here. So we have our more births. We're going to leave our deaths the same because we're not looking right now. We're saying that the deaths are the same, but the births are increasing. So how does the zooplankton population relate to this? In other words, what has to happen to this population in order for this population to have more births? Well, there needs to be more births in the zooplankton population also, and there's going to be the same amount of deaths. Now remember, this is all about energy transfer and energy storage molecules. So in order for the moon jelly population to have more births, there needs to be more births in the zooplankton population. So the next thing we're going to do is we're going to show our energy storage molecules, and we're going to represent those by putting dots in our arrows. So in a stable population, we're going to say we have 4 dots, okay? Now when that zooplankton population increases, what happens to our energy storage molecules? They increase too. So instead of 4, we went ahead and put 8. So now you're ready to try this on your own? Take a moment and read over page 65. So the model we just created was in regards to the moon jellies and the zooplankton. This time you're going to create a model and show the relationship between the moon jellies and the leatherback turtles. So I want you to pause this video and try to create your own model. Okay, pause it. I'm serious. Pause the video. Okay, so I'm hoping you paused the video and you didn't just wait for me to go on and give you the answers. But now keep in mind, your model doesn't have to look exactly like mine. We just want to get them similar, okay? So let's take a look first at our graph and let's see what it's telling us. It's showing us the populations in a stable ecosystem between the moon jelly population and the leatherback turtle population. And then we're going to show our populations during our moon jelly population explosion between both the moon jelly population and the leatherback turtle population. So first things first, I'm going to stick 2 Bs in my bottom box because our births didn't change for the leatherback turtle population. Our births stayed the same. But what did happen is that there was an increase in deaths in the leatherback turtle population. So I chose to put that there were 4 deaths in the leatherback turtle population. Again, we're just trying to show more deaths than the stable. So if you put 3, that's fine. If you put 5 X's, that's fine. If you put 6, that's fine too. The concept is we had more deaths than before. So what happened to the moon jelly population? How did the deaths of the leatherback turtle population affect the moon jellies? Well, in the moon jelly population, our birth rate stayed the same because the death of the turtles isn't going to affect the birth of the moon jelly. So we had 2 in the stable environment and we have 2 in our population explosion. But what happened is we have less deaths in the moon jelly. So if you look, originally we had 2 X's up here in our stable ecosystem, but down here I only have 1 death. Now let's look at our energy storage molecules. In a stable ecosystem, we're going to use our number 4. We got 4 over here transferring to the leatherback turtles. But when more leatherback turtles die, there's less energy storage molecules transferring over to that population. The reason? There's less leatherback turtles eating. When we ask the question, what could have caused the size of the moon jelly population to increase, we have 2 claims that we can make regarding the increase of the moon jelly population. The first claim is that a change to the zooplankton population caused births to increase in the moon jelly population. Because remember, the model we just created, we could show there was more births in the moon jelly population because there was more zooplankton, and those zooplankton created more energy storage molecules for the moon jellies to eat. The second claim we could make is that a change to the sea turtle population caused the deaths to decrease in the moon jelly population. So, less sea turtles floating around, less moon jellies getting eaten, which means there was more moon jellies to swim around. Now, all of this got me thinking, leatherback turtles, moon jellies, leatherback turtles. I wonder what it looks like when a leatherback turtle eats a moon jelly. So YouTube again to the rescue. I went online, found this great video of a leatherback turtle eating a moon jelly. And I thought it was so cool because there he goes. Yep, chomping down. That's his dinner right there, lunch. Take a look. Let's look at that in slow motion. 1, I think it's 3 bites he takes. 2, and 3, and that moon jelly is gone. So one thing I have to say, I love sea turtles. He's absolutely beautiful to me. When I was in Maui with my dad, I went to a town in Maui called Kihei, and off the coast of Kihei, there was actually like a little, I don't know if it was a marine preservation place or I don't know what the deal was, but somehow we got to swim with turtles. Like it wasn't like, you paid money to go swim with the turtles. Literally, we walked on the beach, walked into the water, started swimming around, and we were swimming with turtles. And I actually have a picture of swimming with a turtle. It was absolutely amazing. But aren't these just so beautiful? Okay, back to our lesson. So now we have our evidence. We're going to take a moment. We're going to evaluate our evidence. So go ahead, look on page 67, and our evidence criterion, and we're looking for samples that represent as much of the whole as possible in order to provide stronger evidence. So what I want you to do is take a moment, read over page 67, pause the video, and then come back to me. Okay, so the next thing we're going to do is we're going to evaluate some evidence. And again, we're asking that question, what could have caused an increase in births or a decrease in deaths in the moon jelly population? So if you turn over to page 67, let's look over this. First of all, our evidence criterion. Samples that represent as much of the whole as possible provide stronger evidence. So we're going to look at some evidence cards. We are going to read and annotate those evidence cards. And if you're wondering, where are those evidence cards? Well, if you just turn your page over to 69 and 70, the evidence cards are there. And what we want to look at on the evidence cards is how are the samples described on each card different? We want to look at which sample best represents the whole population. If you're wondering where I'm at, I'm just reading the directions on page 67. And we're going to note that both the zooplankton and the sea turtle populations can be found throughout Glacier Sea. It also says to discuss your annotations with your partner. So if you have a parent, a sibling, or your stuffed animal, or your pet snake or cockatoo works too. And you're also going to sort or rank the evidence cards. So this says sort them and place them on the evidence gradient. I'll show you what the evidence gradient looks like, or you can just rank them from strongest to least strong. And that's personally what I did. So let's take a look really quick at the evidence cards. So here's our evidence cards. What I want you to do is take a moment and examine very carefully the evidence cards. They're over on page 69 in your notebook. And there's 2 of them for the zooplankton. On page 69, just take a moment, write some notes on them, what you notice, what you see. And remember, take a look at the key. This tells you what the little symbols on the evidence cards mean. Then you're also going to do the same thing for the leatherback turtles. This is over on page 70 of your notebook. And there's evidence card C and evidence card D, and you're going to do the same thing. Just make notes on them. See what kind of information they give you. And then as far as your evidence gradient goes, you can just write right on the cards. And we're thinking in terms of stronger and less strong. So I want you to put a big star on the card that you think is the strongest evidence. And then you're going to rank the other ones going backwards, saying this is my strongest one. And then if you think evidence card B is the next strongest, you'd say it's the next strongest. And then if you think C is kind of over here, you could put it like that. And then if you think D is the weakest, you'd put D as the weakest. Did I say D twice? I'm not sure, but you get the idea. You're basically going to rank the cards. So go ahead, pause the video. I want you to evaluate and annotate your evidence. So write notes on there, circle things, highlight things, and then rank it. So put a star on your best one, and then rank them from the strongest all the way down to the least strong. Okay, pause the video and take a moment and do that. So now that you've got your evidence cards all annotated and evaluated, I'm going to take a moment and just show you what I did with my evidence cards. So these are some of my annotations. I started with evidence card D, and I noticed something. I noticed that there was one location where there was data collected. And I noticed that that location was close to shore. That says shore. It looks like shoe, but it's shore. And I noticed that it was close to the research station, because here's my research station here. And I don't know if that has any bearing, but it was something I noticed. And I also noticed that there was no other data collection points in this whole area there. Okay. For evidence card C, I noticed that there were 3 locations where the data was collected. I noticed that one of them was close to shore. I noticed that 2 were far away. And I also noticed that there was no data collection points taken in this area here. I also noted that this one was also close to the research station. Okay, for evidence card B for our zooplankton, I noticed that there were 6 locations where data was taken, and I numbered them. I noted that they were all really close to shore. I noted that 1 was right by the research station. And I also saw that there were no samples in this area taken here. So I don't know if that makes a difference or not. I don't know if the conditions are different out here, but I did notice that there was nothing here and that they were all close to shore. And finally, for my last evidence card A, I noticed that there also were 6 locations, and I numbered them, and that they were all over. Some were close to the shore, some were farther away. There was ones in the middle. I did notice that there wasn't one quite as close to the research station, but again, not sure if that makes a difference or not, but it was something I noticed. And I thought that because the locations were all over, there was 6 data points instead of 3 from the Leatherback Turtles, that this was going to be the strongest evidence. So I stuck my star on evidence card A for that reason. Okay, and this is how I ranked my evidence. So I ranked A as my strongest piece because, again, there were 6 data points and they were all over. I ranked B as my second strongest because, just like A, there were 6 data points, but they were closer to the shore. But there were still more data points than the leatherback sea turtles. I ranked evidence card C as less strong than B because there were 3 data points. They were spread out, but there's only 3 of them. And evidence card D was the least strong piece of evidence because there was only 1 data point. All right, give me a high five, virtual high five. Woohoo! Good job on accomplishing that. So we're going to move on now to your homework. Technically, this is part of the Tuesday, Wednesday homework, but I'm going to go ahead and go over it. If it was me, I'd go ahead and just get it done. That way it's out of the way. You don't have to think about science other than looking up Mr. Vandergrift's cool science demos, which, by the way, how many of you have done those? I've attempted one of them. I tried one of the ping pong ball with the hairdryer. I had this like little spiky ball. I'm looking on my desk. I don't see my spiky ball. I'll have to find my spiky ball. And I tried it with the spiky ball and it didn't work with the spiky ball. So I want to try another ball and try to get it to like fly up in the air like he did with the hairdryer. Anyways, moving back to our homework. Okay. So what you're going to do is you're going to review the evidence. So, and you're going to decide which claims you think are supported. So remember, the evidence is your evidence cards. These guys. Am I showing that? Yep, there we go. These cards. And remember to think about which sample best represents the whole population. And I'm basically just reading over page 68. Look back at the models you completed in class. Those are on page 64 and 66. And show the claim that you will support. You can use one or both of the models to help you plan your argument. Now, for your argument, I want you to state your claim. And the next slide is going to show you the claims, or you can just look down a little further on page 68. You're going to describe your evidence. So tell me, what is it showing you? You're going to make your argument as convincing as possible by making sure you explain how your evidence supports your claim. So how do they go together? And then I want you to read over your completed argument. Is it convincing? Did you use your scientific words such as consumer population, research population, energy storage molecules? Okay. Now, remember, we talked about what are the claims. So again, question we're answering, what could have caused the size of the moon jelly population to increase? And we're saying the population increased because either a change to the zooplankton population caused births to increase in the moon jelly population. Or the other claim is a change to the sea turtle population caused the deaths to decrease in the moon jelly population. So once you're done with your argument, either what you typed up or what you wrote, go ahead and email it to Mr. Vandergrift. And I put his email on the screen. It's mvandergrift@ramonausd.net. And you can, if you typed it up, great. You can just send it that way. Or if you wrote in your book, that's fine. Just take a picture and email it to him there, okay? Because we have something we're going to do with those. So hold on one second. Don't go anywhere. There's still something you need to do. Flip over to page 72 in your workbook. And once you have completed your argument, I want you to go through page 72 and 73 and just do a self-assessment. So what you're doing is you're checking your understanding. You're asking yourself, did I understand the concepts presented? And you're kind of thinking about it a little bit. And self-assessment is really important. You may think like, oh, this is pointless, but it's actually really, really important. And the reason is it helps us to learn. It helps us to become better learners. For me personally, I was doing a self-assessment the whole time I was planning the screencast and going over the lesson. I was asking myself, do I understand what's going on? Do I understand the background information? Do I understand how the moon jellies relate to the zooplankton and to the leatherback turtle? So even I was doing self-assessment. So it's a good practice to get into. And I have one more thing for you. I want to know if you have questions about the moon jelly population. So if you do, what you can do is you can post them on our Moon Jelly Padlet. You can either take your phone, scan the QR code, and it'll pop up Padlet, and you can put your question right up, or you can type in this link right here. It's just bit.ly, it's bit.ly, and then it's just /Moon Jelly Padlet. And that will get you onto our board. So we can see if we have any other questions about moon jellies. I know I've got a couple questions about moon jellies. So there we go. Awesome job. Have a great rest of the week. And I will see you on Tuesday in our Zoom call. I'll be there. Okay. See you later. Bye.